Alright, first off, I just want to say, you don't know how hard it is for me to sit down in front of this camera and not laugh my ass off just looking at it. But, I'm making my first video today, and it's on the general topic of aliens. It's not about, like, UFOs or conspiracies or anything like that. It's more based on, like, the biological aspect, and if it's even possible aliens are out there, you know? Like, is it possible for them to be out there based on the biology we find in space and stuff like that? Alright, I told you guys I don't know what the fuck I'm doing, and I really don't know what the fuck I'm doing. Especially when it comes to editing videos and stuff like that. So when I thought of how I'm going to do my videos, I thought, what am I good at? And the answer is PowerPoints. Because I've done so many of them. And here's my PowerPoint. Now, as you can see, got the aliens, cat, ancient aliens guys here, right there. And the title is Alien Beginnings. Of course, it's by me. Filmed on June 1st, 2012. I hope. Well, of course it is, but I hope I upload it then. Alright, now the topic, what I'm talking about. Right here, first one, carbonaceous chondrites. What are they? They're basically meteorites, alright? They formed during the early solar system. So when they formed, you know, it was 4.5, 4.6 billion years ago. So they're really old. You know, some say they formed even before the sun. They formed in oxygen-rich environments. There's different groups of them. The main one that I'm going to talk about today, or the only one I'm going to talk about today, is the Murchison meteorite. It belongs to the CM group. Now, carbonaceous chondrites are rich in carbon. And one thing about the CM group is that they have a lot of amino acids and stuff like that. They're found with a lot of organic compounds on them. Now, one thing about these meteorites is that they drifted through the gas and dust of the early solar system, collecting basic organic chemistry from around that time. So we get to look back at what it was like back then, basically, when we get them. On to the next slide. So the Murchison meteorite, that's the picture of it right there. I'm sure you guys can see that though. Now, it fell in Murchison, Australia in 1969. Contains the building blocks of life. Some of the things it had were amino acids, sugars like polyols, carboxylic acids, and more than 14,000 unique molecular compositions. Now, there may be 50,000 or more compositions. Hold on a second, let me look at my notes. Now, they say there may be more than 50,000 because of the limited scope of the mass spectrometry analysis that they did on it. You know, they didn't look at everything, they just, you know, kind of looked at a specific spot, not really specific, just a spot, and saw what they could find. You know, they weren't looking for anything in general, just what was there. And because each collection of atoms can be arranged in numerous ways, the authors estimate, the authors of the article that was published, that there may be millions of distinct organic compounds in the meteorite. So, they have a lot of stuff to do to find out. Now, the importance of these findings. The importance of finding sugars in this meteorite is sugars are constituents of cell membranes and are also cellular energy sources. So they make up cell membranes, or a part of what makes up cell membranes, and they're necessary for the metabolism in your cells and stuff like that. They're also components of genetic material like DNA and RNA. You all know what DNA is, I'm sure. But I have a slide talking about RNA, in case you guys don't know what it is. So a little biology lesson. Now, amino acids, those are the building blocks of proteins. They're present in all known life forms, and more than 50 that were found on this meteorite are extraterrestrial in origin. So that basically shows that there are amino acids out there found in other places than Earth, and if they're a building block for life, then it's possible that somewhere else other than Earth, you know, has life. Carboxylic acids, those are a common type of organic acid. They're found in ants as formic acid, in lemons as citric acid, and etc. Kind of fucked up right there. Well, let's go on. Here's the RNA slide. There's a picture of RNA, or what it's doing at least. Can't really see it, see if I get closer. And you still can't see shit. So let's back it up a little bit. Oh. What is RNA? One type of RNA, messenger RNA or mRNA, is responsible for the production of polypeptides. The produced polypeptides fold into all or part of a protein. Now, what is a polypeptide? It is a chain of amino acids. So basically, you get these chains of amino acids that form polypeptides, and those form proteins, and proteins are necessary for everything. You know, they make your hair, your nails, stuff like that. Everything. One theory of how life emerged. Now, first let me talk about this. So you have all these amino acids and stuff like that, sugars, everything, kind of floating around space, I guess you could say. Now here's one theory of how life emerged on Earth. You started off with the abiotic synthesis of small organic molecules, such as amino acids and nucleotides. We know what amino acids are. And you have the joining of these molecules into macromolecules, including proteins and nucleic acids. The next step is the packaging of these molecules into protobionts. They're basically like water droplets with a cell membrane, basically. Like it says right there, droplets with membranes that maintain an internal chemistry different from that of their surrounding. And then, following that, you have the origin of self-replicating molecules that eventually made inheritance possible. So, if that's a theory of how life started here, then maybe it's possible that life started in these steps somewhere else, in different galaxies, in this galaxy, throughout the universe. And here's some thoughts. Let's see. I'm not going to read all those quotes, but you get to look at it. I'll let you stare at that for a little bit so you can read it all. I mean, you could also pause the video if you wanted to. But who knows? I mean, my thoughts are, if these amino acids and sugars and everything are out there, and they are the building blocks for life here, then maybe it's possible that since, I guess you could say, they're in abundance on these meteorites, then you could find them on other planets. Now, one of the theories of life is that these amino acids and sugars and everything on these meteorites, when the early Earth was formed billions of years ago, is that they came raining down and brought, basically, all of these amino acids and sugars to the Earth. And that's what started out the process of life, I guess you could say, you know. And if it's possible that that happened here, then why isn't it possible that it happened somewhere else on a planet that is suitable for life? Now I also want to show you one other thing. It's a link. Oh, mass spectrometry. Do you guys want to know what that is? It is an analytical technique that measures the mass to charge ratio of charged particles. And blah blah blah. It's used for determining masses of particles, for determining the elemental composition of a sample or molecule, and for elucidating the chemical structures of molecules such as peptides and other chemical compounds. And I'm not going to read all that because that's not really what I wanted to show you. It's just what happened first. Alright, here's what I wanted to show you. See if I can zoom in on that. Oh, that's pretty shitty. Zoom. I'll just move it forward. And that's pretty shitty too. This is from NASA's website. And it says, the title of the article is Meteorites Reveal Another Way to Make Life's Components. And what I wanted to show you is this right here. But also, I'll just read it to you because you can't see it. Creating some of life's building blocks in space may be a bit like making a sandwich. I like sandwiches. You can make them cold or hot according to new NASA research. This evidence that there is more than one way to make crucial components of life increases the likelihood that life emerged elsewhere in the universe, aliens, according to the research team, and gives support to the theory that a kit of ready-made parts created in space and delivered to Earth, like I was talking about the amino acids on the meteorites coming to Earth, let's see, made parts created in space and delivered to Earth by impacts from meteorites and comets, assisted the origin of life. So if it's possible that that happened here, I'm sure it's possible it happened somewhere else too. And that's pretty much it for the video. Pretty sure it's probably a long ass video. I just want to give a shout out to Jonathan Zalecki And a shout out to Victor Suero, because it's his birthday today. Happy birthday, brah. And that is the end of this. So peace out.